Hello, in this video we're going to be talking about the chain rule, which is finding the derivative of composite functions. In order to do the chain rule, one of the things that we need is this idea of an inside function. So when we have a composition, say we wanted to find the derivative of this thing, this is actually a composition of two separate functions. There is this inner part of 6x minus 5, and then this outer part of x to the 4. So really, this is a composition of 6x minus 5 and a to the fourth. In this example, it looks like there's like three things going on, really only two, because we've got that innermost thing. That innermost thing is x plus 1. Sure, we've got a fraction and a square root, but then that fraction and square root could be written as a 1/2 exponent. So that is the outer function, and that inner function is the x plus 1. In this example, we've got that inner thing. But what is the inner thing? Is it the x? No. That's going a little too far. What we want is that cosecant. That cosecant is our inner piece, and then our outer piece is that cube. Yes, there is sort of an inner piece of that cosecant with an x, but you could do that, but then there would also be an inner piece of this one with an x, and an inner piece of this one also with an x. So that inner piece that we care about in this example is just that cosecant. So here is the chain rule. In order to do the chain rule, if you've got this composition, you do the derivative of your outside, leaving that inside alone, and then multiply by the derivative of whatever inside. So in this example, we have an inner piece of this square root of 3x, and then we find the derivative of square root of 3x to be just the square root of 3. So to find this derivative, we need to do the derivative of the outer part, the derivative of cosine, to get this negative sign. Note that the square root of 3 did not change. This inner piece does not change. Then we multiply that by what was inside of our cosine function, this square root of 3x. We multiply by its derivative, square root of 3. You could then rewrite this so that it's a little bit neat, but that's about all you need to do for chain rule. Now, this chain rule can get somewhat complicated. In this example, I've got a fraction inside of a squared operation. So that fraction is my inner piece. And then we need to actually do quotient rule in order to figure out what the derivative of that inner piece is. So I get all this stuff. I get 1 over 1 plus cosine of x. This video is not about quotient rule, so I'm just going to have that there. So to do our actual derivative, we need to do the derivative of this outside piece, which is that square root. So that is going to be a 2 multiplied by what was inside. And what was inside does not change at this point. Note that this 2 became a 1. Then we need to multiply by the derivative of what was inside. That's where all this quotient rule stuff comes into play. So we need to multiply by this 1 plus cosine of x. And then that's it. Like, we could clean that up a little bit by, that 1 plus cosine of x's could be put on the bottom squared, throw the 2 up top. But we just do the derivative of the outside, leave the inside alone, and then multiply by the derivative of what was inside. In this example, I want to see what is my inside function. My inside function gets a little bit weird because my outermost thing is that squared. So inside of that squared, we have a sine 3x minus 2. So when I go to do the derivative of my inside, kind of prepping for this chain rule, I end up with the derivative of the outside. Derivative of sine is cosine. Leave the inside alone. But that has an inside as well. There's a chain rule inside of this chain rule. So then we kind of have this w equals 3x minus 2. And this w prime, its derivative is just 3. So this cosine of 3x minus 2 also gets multiplied by a 3. We get a chain rule in this chain rule. Then we go to do the actual derivative of y prime. Our derivative of the outermost part, derivative of a squared, is just a 2, keeping that sine of 3x minus 2 alone, and then multiplying that by our this thing, the derivative of the inside. What is the derivative of that sine 3x minus 2? That is our derivative. If this was a free response question, I would just stop there. I would be done. Multiple choice, they might get a little bit weird with it. Y prime can be written as, well, this piece right here. You might or might not remember it, but that is sine double angle. Maybe sine double angle says if you've got a 2 and then sine and cosine with those insides being the same, we can rewrite that as a sine of 2 times 3x minus 2, and then multiplied, oh, nope, forgot to close that, multiplied by this 3 that was left over here. Remember? So we get a little 3 there. So this could be written a little bit simpler, but we're not in the simplification game, of sine of 6x minus 4. The Finney textbook in the back does this. It's mainly to prep for BC calculus, really needs this idea. But in terms of AB calculus, you don't need to do a lot of the trig identities. In this example, I need to do a product rule in order to find the derivative of this thing with respect to theta. So when I'm looking to find the derivative, I'm going to look at each bit to kind of like prep for my product rule. F of theta is sort of my first bit. So secant of 2 theta. Derivative of secant is secant tangent multiplied by the derivative of what was inside. So I have to do a chain rule on that secant. So f prime of theta, that first thing of theta, its derivative is secant of 2 theta times tangent of 2 theta multiplied by 2. And then tangent, the derivative of tangent is secant squared multiplied by the derivative of what is inside secant squared. And that turns out to be secant squared 2 theta, and the derivative of 2 theta is 2. Now it's time to write this big old mess of stuff, so I prepped a lot of space. Make sure you've got space. We need to do the derivative of that first part. So that is our secant 2 theta, tangent 2 theta, multiplied by 2. Well, so that's derivative of the first times the second, so that is just the tangent of 2 theta, plus the derivative of that second thing, which is secant squared 2 theta multiplied by 2. And then our first thing, so that is secant of 2 theta. If we wanted to, we might they'd probably clean this up in like a multiple choice question. This would be 2 tangent squared, because we got 2 of these tangent 2 thetas, secant 2 theta, plus we get another 2, and we've got secant squared and another secant, so we got secant cubed 2 theta. So that is our dr over d theta, our derivative. Oh, hi. Our derivative with respect to theta. That's the end of our video on the chain rule. Mel says, bye. You need to find the derivative of the outside multiplied by the derivative of the inside. Make sure you leave that inside alone when you're finding the derivative of that outside. Thanks for watching. Goodbye. I'm going to go play with Mel. Yeah.